Hello everyone, thank you so much for clicking on this video. Today we will be going over an Algebra 1 workshop, lines in specific, so it's super exciting. So before we jump right into the video, let's talk a little bit about me. My name is Tanmayi Sayani. I am a junior in high school here in New Jersey. Some things I like to do for fun are taekwondo, reading, and also baking a little bit. Now, for a description of the course that we're going to be going through in this video. So in this course, we will review lines, super duper exciting, specifically how to draw a line given an equation, how to write an equation given a line, how to write an equation given points, how to determine slope, and how to determine the y-intercept. If you have no idea what some of these words mean, do not worry, we will go over them in great detail. But some things that you should know before we start this course and going through these problems, things like that, are a little bit about fractions, right? Like what fractions mean, how to simplify fractions, and also negative numbers. You should be familiar with negative numbers as we move into slopes, negative slopes, things like that. So if you guys are good with that, you will have no problem going through this course with me. So to start off with the basics, one thing that you absolutely need to know, and for this course I recommend that you have some paper, a pencil to take notes during it, and your first note should absolutely be the equation of a line, which is y is equal to mx plus b. Now these might just look like letters to you, and you're probably like, what are letters doing in math? Don't worry, it's not as scary as it looks. So to start off, let's talk about what a point is. A point is any point that can be on a graph. And if you don't know, this is a graph right here. It's kind of like a grid. Any point that can be right over there that's on this line, right? And a point can be written as x, y. This x value over here determines the number that is on the x line, which is this horizontal line right over here. Anything on that x line is there, all right? The y point is any number that is on this y line or the y-axis, all right? This is known as the x-axis right over here. This is known as the y-axis right over here, any number that's on that. So if we have a point 2, 2, since it's x, y, the first number you should be looking at is our x value, which is 2. We look on our x-axis for the number 2. We're going. We stop at the number 2, all right? And then we have to look at our y value, which is also a 2. So we're looking on this y-axis right here, going up, stop. We're at 2. And this is our y value right here. So at the point 2, 2, this is our value right there. So again, the x is the number on the x line for a point. The y is the number on a y line for the point. Now m is something that we will be going over, is known as the slope of a line, which can also be known as rise over run. We'll go through this more as we go through the video, but these are just some things that you should have in your notes before we start. And the b value that we see right over here is the point where the line goes through the y-axis. So remember, this is our y-axis right here. The point where our line is going right here. So in this case, our b value would be 0 because the y value that it is going through is 0. So we'll take a second to pause this video and write all this stuff down. All right, so the first thing that we're going to be going over is slope. So what is slope? What even is slope? You're introduced to this huge, big idea. Most of the time, you're not even told what it is. So slope is basically how steep a line is. The bigger you have a slope, the steeper that line will be, right? So if you're going on a roller coaster is no fun if it's super flat, right? No, that roller coaster needs a super big slope so that it can be super steep, all right? But something like a train, if you're trying to get somewhere, chances are you don't want to be scared of it. You don't want it to be steep, right? So you want it flat. So you want a flat, lower slope. That's not very flat, but a straight lower slope of probably 0, which we'll get more into after. So just for our warm-up, we talked a little bit about plotting points, but I want you guys to plot some of these points that are over here, right? And for now, I want us to ignore letter G. So I want us to plot A, B, C, D, E, and F. Take a second, pause those videos, and just write the coordinate points. Remember, that's written as X, comma, Y. All right, so let's get into plotting some of these points. So for A value, remember, we need to look on the x-axis first. So looking on the x-axis, y-axis. You can always label them, all right? Looking on this x-axis, we got A. We notice that it stops at 5. So this is 5 here. We know this because 4, 4.4, 5, 5, 5.5, 6. That value I kind of covered up over there, but just remember we're not doing G. All right, so we're at 5 as our x value. So 5. And then we have to look on our y value all the way up, 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 stopping at 3, 3. So for A, our coordinate point is 5, 3. All right. Now let's look at B, if I can. All right, for B, we're looking on our x line. Remember, x line right over here. We're going. Boom, -3. We know this, -2, -2.5, -3, -3.5, -4. So we know that's -3. So our x value is -3. Then we're looking at our y value on that y line right here. That looks like an x, our y line right there. We're going up, we're going up, we're going up, we're going up, we're going up. Boom, at 1. Our point is 1. All right. Hopefully you're getting the gist of this by now. So let me just write down the rest of it so that we can get super into the rest of it. So your C point should end up being -6, comma, -4. And your D line should end up being 0, comma, -3. And then our E point would be 0, 0. All right. So just really quickly going through it. Boom, C, boom, D, boom, E. All right. C line, we're going. -6x down, -4. That's our C line. All right. Where are we on? D, our D line. We're looking at our x-axis right here. We're going, look at 0, boom. We go down, 0, -3. There's our D value. All right. The same thing for the E value. We're looking on our x-axis, looking. Good. Sorry, my graph is getting very messy. This is how I do math, but we're looking at our x-axis right over here. We're going, boom. We stop at 0. All right, this point that will always be the point where both your x-axis and y-axis intersect will always be 0, 0. You guys need to know this, all right? That's the one thing that you should remember about graphing, all right, if anything. So we're seeing it's at 0, and then our y-axis, when we're looking, is also 0 because those two lines are intersecting. If you have any questions about this, I recommend you rewatching this part and doing a couple more practice problems on it. Good, so now that we've done that warm-up, let's move on to the slope of a line. Slope of a line. So the slope of a line can be determined by rise over run. Now I also want you guys to write this in your notes because it's super important. All right, so it's basically how much, what's the difference if you can go from one point to another? Now, if you guys have learned about fractions, you know that 3 divided by 3 can also be said verbally as 3 over 3. Same with any fraction, like 6 over 8 can be said as 6 divided by 8. 7 divided by 9 can be said by 7 over 9, right? So in this case, we are saying rise over run. What is that the same as? Can you guys maybe guess, write it on your paper? Good, exactly. It's rise divided by run. So I want you guys to think of it logically like that. So when you're finding the slope of a line and you're given a graph, all you need to do is count how much it is going from one point to another. So when you're determining what point to pick, it's easiest to pick a point where it goes to the middle of the grid so that you know it's exact, right? So right now I picked 4. There's 5 options right here, all right? So the first thing that you need to do is rise. How much you can rise, all right? So here I'm rising 1, and then I rise 2. So my rise in this case is 2. I'm going 2 up to go to the next point. Now running is how much I can go left or right? Rise is how much I can go up or down. Run is how much I can go left or right. And in this case, I can go right 1. So I can rise 2 and run 1. Now that means my slope is 2 because we know how to reduce fractions, and 2 divided by 1 is 2. So in this case, the slope of my line is 2. Now let's try the same thing for this line right over here. Remember, rise divided by run, or rise over run. Now I see a bunch of points here, so I'm just going to plot them where they intersect through the grid nice and neatly. There's another one, and yeah. Now I can look at any point and the value will always be the same. So when I'm rising to go to the next point, I'm noticing that I rise 1. I'm rising 1, all right? And then when I'm running, I am going right. 1, 2, 2. But if I want to double check, I can do it again. To go from this point to the next point, I'm rising 1, and I'm running 2. Same thing for the next one. Rising 1, running 2. Rising 1, running 2. Rising 1, running 2. And this will be the case no matter what point you pick. And let me tell you why. Ooh, did not spell that right. Rise over run. All right, so in this case, the slope of this line will be 1/2. All right, because we're rising 1, we're running 2. But what if I picked this point over here and this point all the way over here? Will the slope still be the same? It would. And that is what makes a line super special. So let me show this to you guys. So we're going up 1, 2, 3, 4, 5, right? So we're rising 5. We can put 5 up here because we are rising 5, right? And we are going over, running to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 over 10. Now, what do we know? We're simplifying fractions. What is 5 over 10, or 5 divided by 10? 1/2, exactly. So in simplest form, that value in simplest form will always be the slope of your line. All right, let's move on to some different questions. I want you guys to try these on your own, and then we will go over them. All right, so for this first one, let's pick 2 points on the graph. I'm going to pick this point over here, and just for some fun, let's do this point over here. So remember, what is our equation? Rise over run. So how up or down we're going, or how left or right we are going. All right, so in this case, we are going up, rising 1, 2, 3, 4. We're rising 4 over, and we are running to the right. 1, 2, 3, 4. 4 divided by 4 is 1. So the slope of this graph over here is 1. Good. All right, let's move on to the next one. For this one, I'm going to pick this point over here and this point over here. There are easier points that you can pick, but I just want to show you guys how this will work no matter what points you pick. All right. So in this case, you are going to rise 1, 2, 3. So we're rising 3, and then you're running 1, 2, 3, 4, 5, 6. 3 divided by 6. Now, this is not the simplest form. So this is not our slope. All right, our slope is 1/2 because 3 divided by 3 is 1, and 6 divided by 3 is 2. So the slope of this line is 1/2. And remember, slope is determined by the letter m. So we can also write this as m is equal to 1/2, and m is equal to 1. Now, let's move on to some negative slopes. So first of all, to determine whether a slope is positive or negative is basically how the graph looks, right? So think of it like reading a book. You read a book from left to right, correct? So if a graph is going down from left to right, we know that it's a negative slope, right? Because that's just the way it is. But if a graph is going up from left to right, we know it's a positive slope, right? Because we're actually rising in the rising line. Now, when you're determining the slope of a negative line, the formula that you use is still rise over run, right? But it's just a little bit different. So in this case, instead of rising, we're kind of sinking a little bit, but we still call it rise. We still call it rise, all right? So we're rising negative because it's negative. So we're always going to stick a negative in under there. We're rising negative 1, 2, 3, 4, right? So negative 4 divided by positive 1, 2, 3. I don't think. Oh, sorry, I'm looking at the completely wrong thing. Sorry, this visual is just super weird. So right here, we're going down 1, 2, 3, 4. All right, and then we're going 3, 1, 2, 3. So we should have 4/3 as our slope, right? But remember, because it's a negative slope, we need a negative under there. So it should be negative 4/3. Let's do some more practice with some negative slopes, all right? Remember, it's still rise over run. In this first example over here, let's pick 2 points. I'm going to pick this point over here and this point over here, all right? So I'm going down 1, and I'm going to the right 1, 2, 3, 4, 4. My slope 1 over 4, but because it is a negative slope, the slope is negative. Good. And it is the same exact thing for the second one. All right, I'm going to pick this point over here and this point over here. I'm going down 1, going to the right 1, 2, 2, 1/2. Because it's a negative slope, negative 1/2. Okay. For this one, I'm going to pick this line over here and this point over here. I'm going down 1, 2, 3, 4, 5, 6. All right, so I'm going down 6, and I'm going right 1, 2, 3, 4, 5, and 6. So that should be 6 over 6. Remember, negative because it's a negative slope, which is equal to negative 1 over 1, which is equal to 1. M is equal to negative 1. Sorry, that should be a negative 1. All right. And for this last one, right, I'm going to pick this point over here, and let's do this point over here. We're going down 1, 2, 3, 4, 5, 6. We're going down 6. Then we are running 1, 2, 2. 6 over 2, but it's negative. It's going to be negative. It's a negative slope, which is equal to negative 3. M is equal to negative 3. If you have any questions with that, I really recommend that you rewatch this section of the video because we're going to do some practice problems on our own in a little bit. All right, a couple more examples. All right. So this one, let's pick this point over here, and let's pick this point over here. We're going down 1, 2, 3. All right. So we're going down 3, and then we're running 1, 2, 3, 4, 4. Negative 3/4 is equal to m in this example. All right. And in this graph, we have both a positive and a negative graph. So this f of x right here determines this blue line, and this g of x determines this red line. Okay, so let's find the slope of f of x first. So for f of x, I'm going to pick this point and this point. rise 1, run 1, 1, 1. And remember, this is a positive slope because we read a book from left to right, right? And this is going up when we go left to right. So we know it's a positive slope. 1 divided by 1 is equal to 1. So that is the slope of g of x. Sorry, f of x. Okay. Now we're determining the slope of g of x. All right, we read a book from left to right, and this is going down. So we already know this is going to be negative slope, right? So I am going to pick this point over here and this point over here. Going down 1 and going to the right 1, 2, 2, 1 half. But because it is negative, it's going to be negative 1 half. So it's negative 1 half as our slope of this time. All right, now you're going to try some examples on your own. All right, so the answer for this one is m is equal to negative 2/3, and the answer for this graph is negative 3/4. Okay, is equal to m. Now, just going over this really quickly, I pick this point and this point, I'm going down 2 over 3, 2, 3, it's negative, the slope is negative 2/3. For this one, I pick this point and this point, I'm going down 1, 2, 3 over 1, 1, 2, 3, 4, 3, 4, 3 over 4, but that is negative because it is going down when we go left to right. So some notes that you guys should absolutely know, and I recommend that you write this in your notes as well, is that the slope of a horizontal line, which is the line that we see right over here, the slope of that line will always be 0, always be 0. All right, just think of it like this. We're not rising by anything, right? So we're rising by, let's say 0, rising by 0, and then we're running by however many we're going. And we're running by infinity, let's say. 0 divided by anything will always be 0. So we know a horizontal line will always be 0. All right. But if it's a vertical line, the slope of that line will always be undefined. Okay, because when you use rise over run, you're rising by so many. So you're rising by infinity. But you're running by 0. You're not going left, you're not going right by anything, and you're rising by 0. And you can't divide anything by 0. Anything divided by 0 is undefined, okay, or undefined. It just does not exist. So anything on a vertical line does not exist. All right, so now that we learned how to find the slope of all different kinds of lines, let's do some more practice. I want you guys to practice it on your own in your notebooks, on your paper, and we'll go over the answers. All right, so the slope of line A, let's pick these points right over here, rising 1, running 2. So my answer is going to be positive 1/2. We know it's positive because the line is going up. The slope of line B, sorry, let me rewrite the 1/2, 1/2. All right, the slope of line B, we also know it's a positive slope, right? So we're rising 2 this time, 1, 2, we're running 1, 2 over 1 is equal to 2. So the slope of that line is 2. Now looking at line C, we determine that it is a negative slope because it is going down when we look at it from left to right, right? So I'm going to pick this point over here and this point over here. We're going down 2 over 1. So we get 2 over 1. But because it is a negative slope, negative 2 over 1, which is negative 2. So again, our answers will be 1/2 for line A, 2 for line B, and negative 2 for line C. Now let's move on to the equation of a line and how to get points on a graph, because we aren't always given a picture when we're talking about lines. So this is another side that I recommend you guys be putting in your notes. Again, the equation of a line is y is equal to mx plus b, where that y is a y value that's on a point, that x is an x value that's on a point, that m is the slope, and the b is the y-intercept. Now, what the y-intercept means is where the line intersects with the y-axis, that y value and where it intersects with the y-axis, or when x is 0, right? So y-intercept will always be 0, comma, y, where the x value in xy is equal to 0. So if you're given this equation right here, y is equal to 2x plus 3, and you're asked, are these coordinate points, are they in value of the equation that's given? You can check, right? So we know that this value right here, that's an x value, and this value right here, it's a y value. So you could plug it into this equation right here. So you can say 5 is equal to 2 times 1 plus 3. 5 is equal to 2 plus 3. Moving on to 5 is equal to 5. Now, we should know that 5 is equal to 5 at this point, so that is true. These coordinate points over here are a value of this equation over here. Now let's try these coordinate points. Our x value is 5, and our y value is 1. So let's set this equation equal by just plugging in these points. 1 is equal to 2 times 5 plus 3. Now, this equation, the way we're setting it up, it isn't necessarily telling us that it's true. It's telling us that this side, so this side over here, that I'm underlining in blue, it should be equal to this side over here. But we don't know if it is, and that's why we're doing this equation, right? So 1 is equal to 10 plus 3. 1 is equal to 13. Is that true? No, that's not true. So these set of points, these points are not equal. They're not a result of this equation over here. All right. I want you to try these equations, not these equations, these questions that are right over here in this you try section, and tell me if you can get some answers for that. All right, so for the first one over here, we're given the x value and asked what the y value is. So what you guys should have done for this is plug in x in this equation. So we're given y is equal to 2x plus 3. All you have to do is plug in 4 in for x. Y is equal to 2 times 4 plus 3. Y is equal to 8 plus 3. Y is equal to 11. So here we know y is equal to 11. And that is your answer for the first problem. Sorry, I'm trying to erase this. All right, so for the second one, it's asking us, is the point 615 on this line? All you have to do is plug in the x and y value. Now we know 15 is our x value, correct? So we know that anything, oh no, what happened? We know that anything that is on this side of the equation, when you plug in an x value, this side over here, it should be equal to 15, right? So 2 times 6 plus 3, it should equal 15. That's what we're going to solve. 15 should be equal to 12 plus 3. 15 is equal to 15. Is that true? Yes. So we know the points 6, 15 are on the line. All right, moving on to the next one. Is the point 8, 17 on the line? For this one, we're doing the exact same thing we did for the last one, right? So we got to plug in y is equal to 2x plus 3. That does not look like an x. Okay, there we go. 2x plus 3. All right, so our y value is a 17. So 17 should be equal to 2 times 8 plus 3. Again, 17 should be equal to 16 plus 3. 17 should be equal to 19, but that is not true, is it? So no, 817 is not on the line. Now, if you were given a graph and asked to write the equation of a line, you're given all the points that you need to, right? You know the slope, you know y-intercept, so it's just a matter of putting it all together. So again, right up here, we have the equation of our line, y is equal to mx plus b, correct? So y is that slope of the line we have, and that y-intercept is where the line crosses the y-axis, 0, comma b, all right? So in this case, when we're looking at the slope of this line, we are rising 1, 2, 3, 4. So we're rising 4, and then we are running 1, 2, 3, 4, 5. We are running 5. Looking at the graph, it is going up when we're looking at it left to right. We know that our slope is 4 over 5, which is written right here. Now I want us to look on the y-axis and see where the line, what the y value is on the line where it intersects the y-axis, which is this vertical line right over here. It might be obvious because it literally says it, but the y-intercept is at the 4 over here. So 4 is going to be our y-intercept right here. All right, now let's put it together. Y is equal to m. Remember we said m is the slope of our line. 4/5 x plus whatever our b value is, wherever it intersects, which we said was 4 plus 4. All right, so this equation tells us that anytime we can plug any of these numbers in, or any of these numbers in, or any of the points that should be on this line over here, if we plug in an x, if we plug in a y, if we plug in both, the statement will always be true. Let's try one, for example. Let's take this point over here, -5, 0. All right, our x value is -5, our y value is 0. All right, so we know 0 should be equal to 4/5 times -5 plus 4. 0 should be equal to -20 divided by 5 plus 4. All I did was pretend like this was over 1, and you multiply it across, so you get -20 over 5. 0, so I'm just moving my work over here. 0 should be equal to -4 plus 4. And what is -4 plus 0? 0 is equal to 0, so that is correct. So this is just an example of how we get points on our line given this equation right over here. All right, let's do some more practice. Okay, so we're given this line over here. So the very first step that you should do is try to find the slope of this line, right? So I'm gonna pick this point over here and this point that is already teal for us right over there. The slope first, we rise 1, 2, we rise 2, we run 1, 2, 3, we run 3. So we know our slope is m is equal to 2/3. All right, m value is equal to 2/3. All right. Now we need to look at where on this y-axis right over here, where does the line intersect it? You guys should probably see it by now, but that is at the -4. So we know our b value or our y-intercept is -4. Now we have everything that we need to write an equation. So all we got to do is put it together. Y is equal to 2/3 x minus 4, right? Now you could say y is equal to 2/3 x plus -4, but we know that a plus and a minus just becomes a minus, right? So this is how your final equation should look. Let's try the next one. First thing that we should do is find the slope. Now I can pick these points over here, or I can pick any other points. I'm just going to do these points because they're bright red, and that just seems like what we should do. We're rising 1, 2, 3, 4, 5, 6, 7, and we are running 1, 2, 7 over 2. Now we know that this is a positive slope, so our m, or m, is going to be 7 over 2. And our b value, when we're looking on our x-axis right over here, is going to be 4, positive 4. Now our equation will be y is equal to 7 halves x plus 4. That is our equation for this line. Let's do some more practice, but with negative lines this time. So again, you should be doing the same thing, finding the slope, all right? So let's see, we're going down 1, 2, 3, 4, 5, 6, 7, 8, all right? And then you are running 1, 2, 3, 4. All right, so you're going down 8, you are running 4. So your m should be 8/4, but get this, it's a negative slope because remember when we're going from left to right, that is going down, so it is a negative slope. All right, and then we look for a b value, which is on this y-axis right here, and we see intersects right over here where I definitely covered it at 2. So our b value is going to be positive 2. All right, so any numbers that are below this origin right here are negative. Any numbers that are above this origin right here are positive. All right, now we just put the equation together. Y is equal to negative 8/4 x plus 2. Now, something you should already be noticing by this time, is any time we have a negative slope, that's when our line is going down, right? So if you don't know, looking at equations, if I give you the equation, y is equal to negative 3x plus 2, you should already know that this line is going to go down when you're looking at it from left to right, just from this negative slope that's right over here. All right, let's move on to the next one. With this one over here, I'm going to pick this point and this point. We're going down 1, 2, we're running 1. Our m is going to be negative 2. And we're looking on our y-axis right over here. Negative 1 is our b value. So our equation is y is equal to negative 2x minus 1. All right, here are some questions for you guys to try. I'm going to give you the answers in just a second. And if you don't understand any of these concepts, I want you to go back and try again until you get the right answers. All right, so the answer for A is y is equal to 4/3 x minus 2. Now remember, you always have to find the slope first, right? You always find the slope, and then you find where it intersects. In this case, it intersects at 2, and the slope, when you count rise and run, should end up being 4/3. For B, right over here, you should get y is equal to 1x plus 1. You look on the y-axis, you find that b value, you get 1. You rise 1, you run 1, you get 1/1, which is equal to 1. Now we know these are all the graphs here are positive slopes, right? We know that because when you look from left to right, they're going up. D, your slope should be y is equal to 1/2 x plus 3. You look on this y-axis, you find 3 as that y-intercept, right? Where that line crosses this y-axis right over here. And then when you find the slope, rise over run, you rise 1, you run 2, you get 1/2. And for E is a very special one. You get y is equal to 1x plus 0, or y is equal to x. Now this equation right here and this graph right here are super duper special. These are known as the parent function. The parent function. So when we learn about transformations in a little bit and how to determine how to graph a line, right? This graph will come in handy because this is the structure for how all these linear equations should go. All right, let's do some more practice with some negative lines. Same concept, but just with the negative symbol in front of it. All right, so the answer for A should be y is equal to negative 2x plus 1. B should be y is equal to negative 1/2 x plus 0, or y is equal to negative 1/2 x, one or the other. I'm sure your teacher will accept either. D should be y is equal to 1/2 x plus 3. Oh, sorry, that is not it. Sorry, I did that one wrong. Y is equal to negative 1/2 x minus 1, right? Because we're looking at that y-intercept negative 1. Then we are going down 1, running 2, down 1, running 2. All right, so we get negative 1/2, negative 1/2. Good. And E would be y is equal to negative 3/2 x minus 3. Looking at that y-intercept, negative 3. Going down 1, 2, 3, running 2. All right. Again, if you have any questions with that, please rewatch this because we're only going to build off of these concepts as we go. All right. Also, if you got another answer for E, that's probably completely acceptable because this graph is a little bit wonky and the slope is not adding up right. But anything that you get for that, as long as you get the gist of the idea, you will be fine. All right. So another way that we should be able to find slope is by these equations that we have right here. So one way that you can do it is y1 minus y2 divided by x1 minus x2, or y2 minus y1 divided by x2 minus x1. So notice that no matter what, either the x values are subtracting, or sorry, either the y2 values are being subtracted by the y1 values, or the y1 values are being subtracted by the y2 values. So we're never switching it up. It's never going to be 1, 2, 2, 1 or 2, 1, 1, 2. It's always going to be 1, 2, 1, 2 or 2, 1, 2, 1. These values right here. All right. So if these make any sense at all, which they probably don't, you'll see that these y1, y2, y values, they represent points, right? So if you're given 2 points, let's say this first value is her x1 value. The second one is our y1 value. Let's call this point 1 and this point 2. All right. On this coordinate point, our x value will say x2, and our y value will say y2 because this is our second point. All right. Same thing for this line. Let's call this point 1 and point 2. This first point over here, we'll call it x1. The second point over here, we'll call y1. And in point 2, the first point we'll call x2. And the second point we'll call y2. All right. So when we're finding the slope of these lines, we said it can be y2 minus y1 divided by x2 minus x1, right? That's what we said. So let's try to find the slope of this first line. So if we're looking for y2 values, we're going to subtract it by that y1 value right over here, which is actually a 1. And we're going to divide whatever that subtraction is, right? We're going to divide that by our x2 value, right, which is 0, minus that x1 value, which is negative 1. Now we know a negative minus a negative will be a plus. So what we get is 1 divided by 1, which is equal to 0. Sorry, not 0. 1. Wow, my brain is just all over the place today. 1 divided by 1 is 0. All right. So that is the slope of our first line. For our second line over here, called this point 1, this point 2. It's the same exact thing. Let's try it with y1 minus y2 over x1 minus x2. Let's try that and see if that also works. We tried y2 minus y1 over x2 minus x1, but let's just make sure this one works too. All right, So let's look at our y1 value. Our y1 value in the 1 coordinate, our y value is 1. All right, let's subtract that by our y value. That's y2, right? Whatever y2 is, which is also 1. Good. So let us divide that by our x1 value, which is -1, the -1 minus our x2 value, 3. So what we got is 0 divided by -4. And we know that 0 divided anything is 0. Now, what do we know about slopes that are 0? What do we know about slopes that are 0? If you look back at your notes from earlier, we know that if a line has a slope of 0, that means that it is a horizontal line. So we know that the line that has these points over here, we know that it is a horizontal line. You can also just see this by the y values being the exact same. All right. Let's work on some fractions. All right. So let's find the slopes of these lines right over here. So here we have 2, 2, and 6, 3, right? So remember, we are doing y2 minus y1 divided by x2 minus x1. Our y2 value over here is 3, right? So this is 1, 2, 1, 2, 1, 2, 1, 2. Those are our values, all right? Our y2 value over here is 3. Our y1 value is 2. We're dividing that by our x1, x2, which is 6, 2. All right, and that is equal to 1/4. All right, we can't see that, but 1/4. That is going to be your answer for the first one, because 3 minus 2 is 1, 6 minus 2 is 4. 1/4 is going to be your slope for these points over here. All right, let's do the same thing for the other one. -7, which is this value right over here, minus 8, which is this value over here, divided by 5 minus -7. We know that those turns into pluses, and so you get -15 divided by 12. Answer for the second one. All right, now let's do the next one. Now for this one, I want to switch it up a little bit because I want my values to add up nicely and cleanly. I am actually going to do y1 minus y2 divided by x1 minus x2, because I already showed you guys that this worked before. So I can use whichever one I want, and I feel like this one's going to work better for this one, for this specific question. So I'm going to do -5 minus -4 divided by 5 minus -6. And we know negative is positive, negative is positive, right? So we get -1 divided by 11 as our slope. All right. Now for our last one, I'm going to use this y2 method right over here. I'm going to do -19 minus -9 divided by -15 minus -7 pluses all around, which is equal to -10 divided by -8, which is the same as 10 divided by 8, because we know a negative divided by a negative is a positive. Now, if you don't understand how to do this, I really recommend that you go back and watch this video on fractions, because again, we are just going to build off these skills. All right, let's do some more practice. I want you guys to try these on your own. Pause the video, take a second, and then I'll go over them. All right, so this first one that we're doing, let's just add it to the equation, right? So we have 6 minus 4 divided by 3 minus -1. We add those, we get our slope as 2 divided by 4. But since this is not in simplest form, it's not in simplest form, right? We want to add it into simplest form, so we get 1/2. We get 1/2, all right? That's our answer for the first one. For the second one, we're going to do 2 minus 1 divided by 1 minus 6. All right, then we get 1 over negative 5. And we don't really like negatives in the denominator. It's not allowed, but we don't like them because they don't look nice. All right, so we're going to bring that negative to the top. So we get an answer of negative 1 over 5. All right. For our third one, we are going to do 6 minus negative 1 over 4 minus 2 until we get plus 7 over 2. So 7 halves is our answer. 7 halves is our answer for that one. All right. And then for that last and final one on this page, we are going to do 0 minus 1 divided by negative 3 minus negative 1, add is equal to negative 1 over negative 2, which is equal to 1/2, because we know a negative divided by negative is a positive. So the next thing that we're going to work on is putting an equation together given points. So the first question asks us, what is the equation of a line with the y-intercept 0, 4 that crosses through the points 3, 5 and 9, 14? Now, at this point, we should understand the basic structure of how to write a linear equation, and that is y is equal to mx plus b. All right, and we understand what these values mean, where y is that y outcome that comes out when you plug an x value into the equation, m is the slope, and b is that point where that line crosses that y-intercept that we talked about. So for this first question over here, the first thing that I would say is to understand what these points are, right? So when we're looking at the point 0, 4, think of it graphically. So let's say we have a little graph over here. We have points 1, 2, 3, and 4 on our y-axis, and we have points 1, 2, 3, 4, going on and on and on for however many points that we need. So when we look at the point 0, we know that this middle over here is 0, right? When we go up 4, we notice that this point right over here, that is our y-intercept, this 4 value. Anytime that we have an x as 0, that will always be your y-intercept, all right? So again, our equation is y is equal to mx plus b. Okay, so we know that in this, our b value, our y-intercept in that first question is 4, all right? That's our b value. So now it's just a matter of doing exactly what we've been doing before. We need to find the slope of these 2 points right here. All right, so it doesn't matter which points you pick, because no matter whether you pick this point over here and this point over here, or you pick 3, 5 and 0, 4, you will always get the same slope. So let me just rearrange this a little bit. We know our b value will be 4, and we're trying to find that m value, that slope value. All right, so just for simplicity, I'm going to end up using these 2 points right here. To find slope, we know we can use y2 minus y1 over x2 minus x1. Or you can use y1 minus y2 over x1 minus x2. It does not matter as long as you're going in the same order of whatever coordinate points you use, all right? So for our m value, we're going to do 14 minus 5 divided by 9 minus 3. And then we end up getting 9 over 6. But this is not our slope because it is not in simplest form. And we can actually divide by 3 in the numerator and denominator, giving us 3 divided by 2. Now in fraction form, we cannot simplify this anymore. So this will end up being our slope, 3 over 2. Now looking at this, we have exactly what we need to put in an equation, right? So y is equal to m, which is 3 over 2 in this case, x, positive 4 is a value, so plus 4. All right? So that is the answer for that first question. If you were to plug in any points, like if we plug in this point over here, you plug in 0 for x, y is equal to 3 halves times 0 plus 4, y is equal to 4 And we know that when x is 0, y is equal to 4. So we know that this is true. It's always important that we check after. Now, what if we're given an equation, what if we're given the equation of a line with the points 0, 6, and 9, 2? So we're given the y-intercept, and we're given one additional point. What do we do? Well, the first thing that you could do is find the equation of the line and then plug in values, all right, which is basically what we did for the first one. So first thing you want to do is find the slope, all right? So I'm going to do 6 minus 2 divided by 0 minus 9, giving us 4 over negative 9. Remember, we don't like that negative in the denominator, so we're going to bring it up to our numerator, which is that value on the top, giving us negative 4 divided by 9. Now, what you could do, you could plug it into an equation to find the b value. We don't need to do that because we already have a b value right here. We already have a y-intercept. Our x is 0, telling us that 6 is our b value. So our b value is 6. So our equation ends up being y is equal to negative 4/9 x plus 6. All right, I'm going to show you another way to do this. So we have our b value right here, and we know the equation y is equal to mx plus b. You could find your m value because you already have all the values that you need over here. And basically, all you need to do to solve this question is find your m value. So you could plug in a point, all right? So if I'm plugging in this point, 9, 2, into this equation, I need my y value. My y value in this case is 2. My y value is 2. I don't know my m value just yet, so I'm going to keep that variable as m. And then I need my x value. So I know when y is 2 in this line, my x value is 9. It's 9 right over here. So I'm going to plug in a 9 plus whatever our b value is. We know our b value is 6, so I'm going to plug in 6. And I don't want to divide just yet for this, and it's just basic algebra at this point. So the first thing I'm going to do is subtract 6 from both sides, because what you do to one side, you have to do to the other. 2 minus 6 gives us negative 4 is equal to m times 9. Our last step would be to divide by 9 just to find that m value. And we end up getting negative 4/9 is equal to m, which if you look back in your notes is exactly the same value that we got as our m value when we did it the first way. So our equation ends up being y is equal to negative 4/9 x plus 6. Either way you do this, you get the same answer. So it's super important to recognize what these values mean and yeah, how you can do them. I'm going to have you guys pause this video and try out this for these points right here. All right, let's go over them. So for this first question right here, for actually both of these questions, we are given our y-intercept, so we already have one step done for us. So the first thing that you want to do is you want to find the slope of whatever is going through these lines. Actually, this value right here is wrong. So we are going to change this value to a 23. So we're going to change to a 23. All right, so if you need to pause this video again, I want you to try to do this equation using the 23. All right, now let's do this. So the first thing that you want to do is you want to try to find the slope, all right? So I'm first going to do 3 minus 8 divided by 12 minus 9. When you do that, you end up getting negative 5 divided by 3. So negative 5/3 as our m value, okay? We already have this b value right here, so it's just a matter of putting the equation together. Y is equal to negative 5/3 x plus 23. That is the answer to this question right here. Now for the second one, when we find the slope, we do 4 minus 2 divided by 3 minus 1. You end up getting 2 divided by 2, which we know is 1, which is our m value, all right? Now we also know that our x-intercept value is 5, so the equation will end up being y is equal to 1x plus 5, all right? So this equation actually won't work graphically, but since we're given the points, logistically this would work. But if you were to put this through Desmos or a graphing calculator, these points would not be applicable to that. Now let's do a little bit of a challenge question. When you're not given the y-intercept, you're not given the y-intercept in any way, how can you solve this line? How can you find the equation of this line? I want you guys to really think about what values you're given, right? How we can plug the values that we have into this equation and use algebra to find whatever we need to find. All right. So the first thing that we're going to do is we're just going to plug in, we're going to find the slope of this line. That's the very first thing that we're going to do. All right. So what I'm going to do is I'm going to do 12 minus 9 divided by 6 minus 5. You end up getting 3 over 1 equals 3 as our m value. So we have our m value as 3. It's not a 3, 3. All right. Now we have our m value. We have 2 other points. So it's just a matter of plugging back into the equation, kind of like that second way I showed you when we were putting that equation back together. So we have y is equal to 3x plus b. Now we have 2 points. We have 2 points. So we have 2 different different sets of x and y values to choose from. So I am going to plug in 5, 9. So I'm going to plug in 9 for my y value, 3 times 5 for my x value, plus b. 9 is equal to 15 plus b, minus 15 minus 15. Negative 6 is equal to b. All right, so that's my b value. Now you just put the equation together. Y is equal to 3x minus 6. This should be the answer that you get no matter which one of these points that you use. You should get the same exact answer. I'm not gonna give you guys extra questions to try for this just because it was a little bit of a fun kind of challenge. If you understood that, congrats. I'm sure the other stuff will be a breeze for you as well. Now let's just review some of the things that we went through. So we learned the equation of a line, which is y is equal to mx plus b. Super important, all right? Where that y represents that y value, the outcome of the equation that we see on that y-axis, right? So we have a graph, and then we have an x-axis, and we have a y-axis. So any number that is on that y-axis for a point, right? So if you have a point, anything that's on that y-axis, that's the y value. The m is the slope of a line, which is determining how steep a line is, right? So a higher slope would have a steeper line, like a roller coaster, and a lower slope would have a flatter line, right? We determined that if a slope is 0, then it's a horizontal line. And if a slope is undefined, then it is a vertical line, right? That x value is any value that is on this x-axis right here in green, all right, on a point. And then b is that y-intercept, where at any point in a line, if it intercepts an x-axis, sorry, with the y-axis, that is the y-intercept. So to find slope, it's rise over run when you're looking at it graphically, how many points you're rising, how many points you're running until you can get the slope of that line. Or you can use the equation y2 minus y1 divided by x2 minus x1. Or like we said, you could do y1 minus y2 over x1 minus x2, no matter what. We know if it's a negative slope, a line has to be going down when you look at it left to right, because you read a book. So if a line is going down when you look at it left to right. The positive slope, we know that the line is going up when you look at it left to right. The line is going up. A negative b value, for the b value over here is negative, it tells us that a line, so if we have a line, right, it's going down that many places from the parent function. Remember, we talked about the parent function a little bit earlier. That b value tells us how down or how up. So if it's a positive b value, it tells us we're going up that many places as well. And that's lines for you guys. This was a little bit fast-paced, so I really do recommend going back on any parts of the videos that you don't understand. And if you have any additional questions or feedback, please email info@designyourcareers.org. If you like videos like this and would like to see more, really appreciate your feedback in the comments. And also make sure to like this video. Thank you, guys.